So our final area of discussion dealing with dimensional analysis has to do with sometimes when you have a unit or a number, a value, a measurement, that you'll have a unit on the top and you'll also have a unit on the bottom. For example, when we talk about a car traveling 70 miles an hour, 70 miles an hour really is 70 miles over 1 hour, and that means that you'll drive 70 miles in exactly an hour. Okay, and when you do that, you might have to convert that to something a little bit more, let's say, sciencey, such as meters per second. Okay, so in this case, we're talking about 70 miles over 1 hour, and we want to convert that to meters per second. Okay, and again, when we do that, I'm going to give you all the conversions you need. The key is, right here, treat it like two different problems. Okay? And if we treat it like two different problems, then we know that we can do the top part first, converting the miles to meters, and then we can convert the hours to seconds. So in this case, that's what we're going to do. We're going to start, so forget about these hours here on the bottom altogether. Just focus on the miles. I need to convert miles to meters. Okay, and so you'll see, here's my conversions right here. So the first thing I'm going to do, since miles are on the top, I'm going to put miles on the bottom. And here's my conversion. 1 mile equals 1.61 kilometers. So then my miles are going to cancel. And again, if I stopped right there, so forget all this other stuff right here. If I stopped right there, my answer, if I took 70 and times it by 1.61, that would be kilometers per hour. So that would kind of, it's about 112 or somewhere around there. 112 kilometers per hour is about 70 miles per hour. Okay, but obviously we need to keep going. Okay, so again, we're not worried about the hours part yet, but now we have kilometers right here. So my next conversion, 1 kilometer on the bottom equals 1,000 meters on the top. And again, what happens? The kilometers cancel. And so now our top part is done. We have converted miles to meters. Okay, now that we've finished that part, now let's go back to the very beginning and let's focus on the hours. And since hours are on the bottom of the fraction, to cancel hours, we have to put hours on the top of the fraction. And even though it's way down there, they're still going to cancel. 1 hour equals 60 minutes. So that hour and that hour cancel. And now we've got minutes, again, on the bottom. So then we need to cancel minutes. So I'm going to put 1 minute on the top from that conversion, and minutes cancel. And notice again that now everything is canceled except for meters on the top and seconds on the bottom. And I know that I have it set up correctly because everything cancels. Okay, and so now we can see we're going to take the number 70, we're going to multiply by 1.61, we're going to multiply by 1,000, we're going to divide by 60, and then we're going to divide by 60 again. Check that on your calculator. You should get an answer of 31.3 meters per second. Okay, example 2. A Ford Focus car gets 38 miles per gallon while driving on the highway. What is this gas mileage in meters per liter? Okay, so let's start by writing down the information that they give us. 38 miles per gallon. That means over gallons. Okay, so again, I'm going to start with miles. 1 mile, 1.61 kilometers, kind of like the last one. And then I've got, and miles cancel. And now I've got kilometers on the top, so that conversion's gone. So next conversion, 1 kilometer on the bottom equals 1,000 meters. Kilometers cancel. And now I've used that conversion. And now I've done the top part. I've converted miles to meters. Okay, now I'm going to focus on gallons. Okay, gallons are on the top, so I'm going to use one of these conversions here to convert gallons to, in this case, milliliters. So 1 gallon, again, has to go on the top, so that gallon and that gallon will cancel, and that's 3,785.4 milliliters. And then my last step, I've got milliliters on the bottom, so I need to put milliliters on the top, so that conversion says 1,000 milliliters over 1 liter, milliliters, cancel. So again, kind of quickly going back through this, the only units I have left, I have meters here and I have liters here. So now I'm going to take my calculator. I'm going to go 38 times 1.61 times 1,000 divided by 3,785.4 times 1,000. And I get an answer of about 16,000. Ooh, that seems wrong. See, this is one of those times where I look at my answer and think, wow, that number is way too big. Okay, but I do have that 1,000 there, and I do have that 1,000 there. That number just seems awfully large. But that's what it is. I'm just checking my math. 38 divided by 1.61 times 1,000 divided by 30. Oh, no, I did it. Oh, no, that's right. Times 1,000. 16,162. Only two significant figures, though, so that does equal just 16,000 meters per liter. Okay. And again, that does kind of make sense because 16,000 meters, a meter is much, much shorter than a mile, so that does actually make sense. Okay, one more example here, and then we'll be done. Okay, example number 3. A beam of yellow light has an energy of 3.35 times 10 to the minus 15th. That's a capital J. That actually stands for joules over photon. Again, it doesn't matter if you understand what the heck's a joule, what the heck's a photon. Don't worry about that part yet. Okay, we'll get there. Okay, all we need to know is they want us to convert joules to kilojoules and photons to something called mole. Okay, so let's just do like we've always done. Even though we don't understand this at all, 3.35 times 10 to the minus 15th joules on the top over photon. And then, just like always, what do we have to do? We have to cancel joules. So here's my conversion. 1,000 joules, 1 kilojoule. And joules cancel. Okay, and now we have kilojoules. That's it. That's all we had to do is convert joules to kilojoules was one step. Now we need to get rid of photons. Photons are on the bottom. We need to cancel those. So here it tells us that there are 6.02 times 10 to the 23rd photons in 1 mole. Okay, and now photons cancel. We've got kilojoules, kJ on the top. We've got moles on the bottom. Sorry, M-O-L-E. We're going to learn about those later this year. Okay, and so I'm going to take 3.35 times 10 to the minus 15th. I'm going to divide by 1,000. And then I'm going to multiply by 6.02 times 10 to the 23rd. And again, gives me a pretty darn big number. I'm going to put it into scientific notation. 2.02 times 10 to the 6th power, and that is kilojoules over moles. Okay, if you left it as, for example, you could have left it as 202 and then 0, 0, 0, 0. That also would have been perfectly fine. Again, you never have to use scientific notation, but it certainly can be helpful. Okay. And that is how you do dimensional analysis problems that involve a unit on the top and a unit on the bottom. Treat it like two separate problems and then do the whole problem all at once when you're all done.